Hello guys! When we heard about radiation, we think radiation is scary because we can't see, hear, smell or touch it. And we know that it can do terrible things to us. Okay. So, to be more understanding about radiation, let's begin with ionizing radiation. What is ionizing radiation? Ionizing radiation refers to radiation with enough energy to knock an electron loose from an atom. Alpha particles, beta particles, positron, gamma rays, and X-rays are all forms of ionizing radiation. But in this video, we'll only focus on interaction of radiation with matter that involves alpha and beta particles only. First, we'll talk about interaction of radiation with matter involving alpha particles. What is actually an alpha particle? Alpha particle is generally termed as 4 helium plus 2, which are in high speed and they are newly released from an unstable nucleus, and usually it is from nuclear fission process. That are by Coulomb scattering or by ionization and excitation of electron. So in Coulombic scattering, normally alpha particle will be deflected from the target nucleus since there is Coulombic barrier. Higher number of proton number, which mean the greater the Coulombic barrier. We see that the alpha particle is deflected since the energy is not high enough to penetrate the Coulombic barrier. But if the energy of alpha particle is high enough to penetrate the Coulombic barrier of the nucleus, thus the new interaction occurs. In ionization, when alpha particles collides with the target atoms, it will experience collision, thus transferring energy to the target atom by ionize the target atom. This causes several or hundreds of free electrons is produced. Let's say it is moved in the straight line, the alpha losing its kinetic energy. The alpha will interact with the free electron by achieving its neutral state. Particles are slow in speed, but the ionizing power is high. An alpha particle also can stop only by a sheet of paper. Beta particle is a high-speed electron or positron, usually emitted by an atomic nucleus undergoing radioactive decay. Beta particles are given off naturally by decaying neutron in radioactive atoms and can be created in particle accelerators. Beta particles have greater speed and penetrating power than alpha particles, but can be stopped by a sheet of aluminium. There are various types of interaction for the beta particle, but we only focus in this video for about 3 interaction only. Bremsstrahlung is electromagnetic radiation produced by the deceleration of a charged particle when deflected by magnetic field or another charged particle. To show how the Bremsstrahlung works, let us imagine this. Let two atoms with different atomic number exist, and let two beta negative move towards the upper side of nucleus while having the same distance between the beta negative particle and nucleus. Thus, this process must satisfy conservation of electric charge, second, conservation of linear momentum and total energy, and third, conservation of angular momentum. Next, we go to this Cherenkov radiation. Cherenkov radiation is electromagnetic radiation emitted when a charged particle, which is normally electron, move through a dielectric medium. While traveling faster than phase velocity of light, radiation is used to detect high energy charged particle. Even at high energy, the energy loss is much greater than the other mechanisms such as Bremsstrahlung. We go to positron interaction. Positron interact similarly with matter when they are energetic. Track of positron is similar with electron in material. When a positron comes to rest, it is interact with an electron, resulting in the annihilation of the both particle. When a low energy electron annihilates a low energy positron, they can only produce 2 or more photons. The production of only one photon is forbidden because of conservation of linear momentum and total energy. The production of another particle is also forbidden because of both particles together do not carry enough mass energy to produce heavier energy, and resulting in the complete conversion of their rest mass to pure energy in the form of two oppositely directed 0.511 mega electron volt gamma rays.